In this video, we're going to talk about the fundamental theorem of calculus, the antiderivative part. So let's say you have f of x equals integral of quantity t plus 5 from a to x, where a is a constant and x is a variable. So when you take the integral, you got to take the antiderivative of quantity t plus 5, and you get t squared over 2 plus 5 from a to x. So using the fundamental theorem of calculus, you get x squared over 2 plus 5x minus the quantity a squared over 2 plus 5a. Now remember, this whole thing is a constant because a is a constant. So now let's say you want to take the derivative of f. So what is the derivative of that? You get x plus 5, and then derivative of this whole thing is 0. So you just get x plus 5. Now take a look at this. Whenever you take the derivative of an integral, there is a shortcut. If this is a constant, if the lower limit is a constant and upper limit is just x, the derivative of an integral is you just have to replace the variable t with x. So you just get x plus 5. So theorem 4, the fundamental theorem of calculus, antiderivative part, says that whenever you take the derivative of an integral of f of t from a to x, that will equal to f of x. And we'll take a look at some examples. So this one says you're taking the derivative of this integral, which is cosine of t from negative pi to x. Notice the lower limit is the constant and upper limit is variable x. So when you take the derivative of this integral, you're just going to get cosine of x. All you have to do is replace the t with x. What about this one? Again, you're taking the derivative of the integral, and the lower limit is a constant and the upper limit is x. So all you got to do is replace the t with x, and you're going to get 1 over 1 plus x squared. Now you have y equals the integral of cosine of t from 1 to x squared. Now notice the lower limit is constant, but the upper limit now is x squared. Notice it's not just x, it's x squared. So how do you find dy over dx, the derivative of y with respect to x? Well, that's going to be, first, instead of t, you got to plug in x squared. But now you got to be careful. What's the derivative of x squared? It's 2x. So you got to multiply by 2x. Now y is equal to the integral of 3t sine t from x to 5. Notice we want the lower limit to be a constant and upper limit to be x. So we could rewrite this as negative integral from 5 to x, 3t sine t and dt. Whenever you change the lower and upper limit, you have to take out the negative. That's one of the properties of integrals. So now, how do you find dy over dx? It's a derivative of this integral over here. So all you got to do is replace t with x and just keep the negative outside. You get negative 3x sine of x. Now you have the integral of 1 over 2 plus e to the t from 2x to x squared. So how would you find dy over dx? Now you got to be careful because lower limit is no longer constant, it's variable. So what you need to do is, first, instead of t, you plug in x squared. So 1 over 2 plus e to the x squared. That whole thing times the derivative of x squared, which is 2x. And then minus, now instead of t, you got to plug in 2x. You get 1 over 2 plus e to the 2x. And that times the derivative of 2x, which is 2. So if you clean this up, you're going to get 2x over 2 plus e to the x squared minus 2 over 2 plus e to the 2x. So this will be your final answer. Now let's take a look at our last example. It says it's about constructing a function with a given derivative and value. It says find a function y equals f of x with derivative dy over dx equals tangent x that satisfies the condition f of 3 is 5. This means when x equals 3, the y value has to be 5. So since we know that dy over dx equals tangent x, we probably need to start with f of x equals the integral of tangent t dt. Now, what do you think the lower limit should be? We know that the upper limit is most likely x, but then the lower limit should be 3 because that is the x value. Now, this is incomplete because f of 3 should be 5. When we plug in 3 for x, we need to get the y value of 5. But when you plug in 3 over here, when you take the integral from 3 to 3, this whole thing is going to be 0 because the lower limit and upper limit are the same. So how can we get 5? Well, all we got to do is just put plus 5. So this way, now when you plug in 3 for x, f of 3 will be 5. So this is what we want.